This is session 4BC, Dynamic Environment Provision, with Reg Wilkinson of Lloyds Banking Group. I'm going to put the feedback link in the chat. Reg has got a combination of slides and video, so be patient as that gets swapped over in 15 minutes or so. Anyway, there we go. That's the feedback. Reg, over to you. Good luck.
Thanks. It's been a fun couple of days with technology. Okay, so I'm Reg Wilkinson. I am a lead engineer at Lloyds Banking Group. I used to be in the development community, and I've kind of moved into more of a full-time DevOps role. So I look after DevOps for the Z platform now. So what I'm going to chat about today is dynamic environments, and particularly how we are using a fully encompassed dynamic environment that not only takes in the infrastructure that we run our tests on, how we manage code, but also how we manage the Z infrastructure components that our applications depend on. So primarily Kix and DB2. So why are we doing this? There's no new reason. I think everything we've got up on the screen just now are things people have heard before. We have a mainframe workforce that is aging. We have got more demand than ever, and the mainframe is still firmly the system of record for lots of very large organizations. And we're in a climate where we've got the regulator is demanding that large organizations effectively take ownership of their critical business systems, and that means you need to be able to put your arms around the entire ecosystem that runs your critical application. So infrastructure in the whole shooting match, which means that the mainframe is still very much at the heart of large businesses today. So how do we make the mainframe more accessible for the next generation of developers? And how do we make the Z technology more accessible for the next generation of workloads? So, a quick disclaimer before we kind of launch into things. So DevOps and Agile, it's all about being flexible and being pragmatic. There are lots of ways you can skin the proverbial cat. There are lots of tools out there that will do things for you. This presentation is how we've tackled the problem of flexibility at Lloyds Bank. It's not the only way you can do things. It's not the only solution. It's not this was invented here. This is a real kind of standing on the shoulder of giants. So we have built chunks of this internally. We have influenced our vendors to make changes for us, and we have used other technologies from the open source community. So it's a real blend of what's out there. So as a team, the Z platform DevOps team within Lloyds have over the last few years generated lots of building blocks for our development community. So we introduced flexible modern IDEs, so things like Topaz Workbench, VS Studio Code. The next kind of challenges were around test environments. So we introduced ZDT, and we started to give the teams platforms where they could have complete control, and that kind of started to alleviate some of the problems about test environments becoming stale or long lead times. We brought GitHub into the mix as initially somewhere to store things like Jenkins pipeline scripts and the jobs that we used to personalize our ZDT environments. And that's evolved. Its use of GitHub, our use of GitHub has evolved over the years. That kind of led us into if we can store things in GitHub and spin things up flexibly, we start to be able to describe our application infrastructure as code. We've extended that capability to allow us to effectively define our route to live as code. So all the supporting infrastructure can now be dropped from GitHub and used to spin up environments pretty much on demand. We've taken that capability and we've extended it further to allow us to manage our KICS and DB2 infrastructure. So KICS CSDs and DB2 DDL, and we can now manage that and do parallel development safely. So these are all building blocks that could be consumed by teams individually. So we don't go out and mandate you have to do everything. We have applications within the bank that generate a lot of change, and they use all our building blocks. We've got applications in the bank which are care maintenance, and they might only get some advantage over you, say, using the modern IDEs. But within the team, you get more bang for your buck the more building blocks you stack up. What we're going to show in this demo is what happens when you use them all. Back down again. So we have adopted GitFlow as the pattern for parallel development safely. We have an internal instance of GitHub Enterprise. So this is a very quick GitFlow 101. So essentially, the main branch within GitFlow represents production. So we would create a development branch for each initiative, which sits under production. And then each developer would then, on their own machine, create their own branch for the feature they're working on. Git and GitHub manages the parallel development safely. It makes sure that developers can overwrite code. They can't promote code back to production without absorbing the change to the same component delivered by another developer. So the diagram on the left is the kind of idealized view. So my first little sketch, which kind of just tracks a feature, one component through its life cycle. So as the color of the dot changes, things have happened to that component. The graph on the right-hand side is one of the teams who are actively using this. And you can see that they have a production branch, which is main, and they have many branches which represent features that they are working on, different initiatives. So by putting GitHub at the center, we get parallel development safely. We get all the protection that Git offers. So how do we apply Git to the mainframe, or how do we apply GitHub to the mainframe? So two different approaches. So for KICS and DB2, we effectively onboard teams. So we will work with a team and we will extract the KICS definitions and we'll extract the DDL from production. We'll work with the team to establish a baseline, and it's amazing the things that throws out. So we ran into the limitation of 1,000 files in a GitHub folder, courtesy of one of our teams who had never cleaned up production definitions for KICS, and they had lots and lots and lots of redundant definitions. Once you have got your definitions baselined, we'll then work with the teams to look at their in-flight changes, and we'll start to create the initial feature branches, the initial developed legs, where their in-flight projects are represented. That means that for KICS and DB2, we've shifted the primary source of truth from the mainframe, and we have a single source of truth within GitHub. Now that means we can now deploy accurately anywhere on our route to live, and all our test environments will be an accurate representation of final production. So obviously we've got scripts within the deployment process which will handle scaling. So the nearer to production you get, the more production-like an environment becomes. So something in production is a Plex, something at unit test level might be a single KICS region, for example. But they're all built from the same version of the truth. Same goes for DDL, for DB2. Again, this is allowed by taking the DDL out of the mainframe and having it mastered in GitHub. We can use our existing tooling. So our approach to this is very much a modernize in place. It's what did we have already that did that job? Does it do the job well enough? And can we wrap some automation around it? So by taking the DDL out using our existing tool sets, we can now make all our environments standard. We can all deploy things consistently. So code this behaves slightly differently. So for code, we are an Endeavour shop. So our primary version of code, so the production version, is still Endeavour, and we still use Endeavour to provide compliance with our risk rules, so things like provenance of code, fingerprinting, etc. But our stack in Endeavour, our route to live in Endeavour is kind of stunted. We start at the system test level, and we build up to production: system test, integration test, holding library, production. What we wanted for parallel development is to make the bottom layer, so the dev and functional test level, as wide as we could possibly make it. So we now have the capability within Endeavour to dynamically create new entry points, so effectively new routes to live for our applications. And those entry points are created with code in Endeavour. So it's actually Endeavour creating new Endeavour entry points for us automatically. We use a component called the Git bridge, which will take our dynamic environments spun up in Endeavour and create a matching Git repository. So where we're taking Kix and DB2 and mastered it in GitHub, code is mastered on the mainframe, but is developed within GitHub. And then we return the code to the mainframe and send it up on our route to live as we deliver change. So on the deployment side, we've standardized on Urban Code Deploy. So Urban Code Deploy has agents run on Z. Urban Code Deploy can deploy Kix changes. It can deploy code changes. It has a RESTful interface. So it can be invoked either through its front end or by APIs triggered by Jenkins scripts, for example. And again, it allows us to deploy a set of changes consistently anywhere on the route to live, and potentially to several devices on the route to live at the same time. So our integration test layer on our route to live can be quite wide. So we might have 4 or 5 environments and running in parallel that are all testing. An application would be using a single environment, but to keep all the environments in sync, we'd want to deploy the change as well as vertically. You'd also want to deploy it horizontally. So we could use Urban Code Deploy to take the same change and to keep all the environments in sync. For our ZDT, we could take a full copy of our application, deploy it to our ZDT environment for unit test, but we could take that same block of code, that same application, and deploy it to a performance test environment. So because we've got a full version of our application, we have got the single version of truth for DB2, the single version of truth for Kix. We can do things like non-functional testing much earlier in the life cycle, because we can deploy those changes to the pre-production box and effectively do a production-like deployment with Urban Code Deploy. So who needs to be involved in setting this up? So we've got 3 personas, or 3 main personas. So we have got Derek, our DevOps engineer. So we effectively offer the development teams within Lloyds what we call a white glove installation service. So we have the process to do something written up as an accelerator. We have a template for the benefits you could get if you adopted this initiative. But we will then go out and we'll work with the individual teams and step them through how they would be onboarded. So it'll be things like we will help the teams request the relevant IDs. We will get them onto Urban Code Deploy. We have got templates for all the components that you're going to need, and we'll help the teams personalize those components. There will be some need for specialist resource right at the start. So for Kix and for DB2, we would need a Kix systems programmer and we would need a DBA, because we need to establish the baseline. So we need to be able to extract DDL for an applications database and we need to be able to extract the CSDs from production, and then we need to work with the application team and the DBA or the sysprog to effectively clean things up and to establish that production-like baseline. Once that activity is done, then the DBAs and the KICS resource are still involved in the process, so they are not locked out. Obviously, we would be expecting them, as usual, to still be involved in the design stage, but when it comes to implementation, they would have the final say. So again, by using Urban Code Deploy, you can build authorization into the process. So the KICS and DBAs would be responsible for 4i checking, authorizing a deployment of a KICS or a DB2 component. And we've got, as part of our tooling, a highlighting mechanism. So if a developer was making what could be a potentially disruptive change, so removing a column from a DB2 table, or changing a URI map, or something that could cause grief if it went wrong, then these are highlighted in the emails that are sent to the sysprogs to authorize the change, highlighting that this isn't just a routine development and you really should go in and check it. So for deployment, we've created a generic Urban Code Deploy application. So the generic application has lots of hooks. So a team doesn't have to adopt all the new processes immediately. They can decide to start with DB2. They could decide to start with KICS or code, or any combination of. And the generic Urban Code Deploy application has hooks for future enhancements. So we could do something similar for IMS. We are looking at things like Java and KICS, so there could be a bundle deployment, which would all hook onto the same Urban Code generic application. So it's done in a way that is expandable for things that we probably can't see coming just now. Okay, so these are kind of the bird's eye view of our DB2 process. So the DB2 is captured from production, it's tidied up. We form a DB2 repo, which is within a GitHub organization that belongs to the team that owns the database. They then use Git flow to develop their DDL. Now, we don't get prescriptive on the tooling, so VS Code, IBM Data Studio, any Git-aware IDE that can be used to manipulate DB2. It's available to the developers, so it's horses for courses. And then through BMC Change Manager, we work out the delta between the master, which is the DDL, which has been extracted from GitHub, and the target environment. So if you are deploying to a ZDT for the first time, the DB2 instance would be empty. So Change Manager would create everything required to stand up the database. If you are using this to go to one of our SIT environments, it'll make sure that the SIT environment is always up to date with the change. That's probably one of the biggest painful maintenance points that organizations who run a large number of test environments in parallel have, is trying to keep these things in sync and retrofitting changes. So now retrofitting changes to the database to environments running in parallel is very straightforward. As soon as you're ready to take that change into the environment, you just point the tool at that environment and it will make the necessary changes. And you'll be instantly running at production level or next release level. Slightly more complicated diagram for KICS, but it's essentially the same story. We've got a master copy of KICS CSDs. for Kix, we use Kix Explorer to manipulate the Kix settings. We've got, again, Kix Explorer is Git aware, so it handles parallel development. And we use Urban Code Deploy to take those settings and deploy them anywhere on a route to live. So that anywhere, again, could be a single environment, or it could be multiple environments in a single hit.
Hey, Reg, I know you were going to pause at the end of this PowerPoint, but the questions are racking up now. So I wonder if you don't mind, could you take a couple of questions?
Yep, let me find my way into the chat. Okay.
So there's one from Kieran.
So when we started using ZDT, did we cut down our old static development systems? Yes. So the ultimate aim, when we started using ZDT, we wanted flexibility. So our static development environments tended to be in groups. So we had an A leg, a B leg, and a C leg. So off those 6 environments, 5 went in the bin, and we kept 1, which is effectively what we call our release bus stop, which is the first system test level on real 10. So from an environment owned by the delivery team, yes, there was a large reduction. What DevOps metrics do we collect? That's a good one. What improvements we've seen in the number of deployments? So from DevOps metrics, we looked at the number of deployments. We captured the number of defects which leaked beyond functional test. So the idea being that if a defect occurred during functional test, that's a conversation between the tester and the developer. If it leaks out of our ZDT environments and onto the route to live, then yeah, we start to count that. And again, we also count incidents after a production deployment. So since we started using DevOps techniques, we've seen bugs jump off a cliff. So literally the graph of deployments versus bugs went like that. So deployments increased. We roughly deploy 1 major release a month, and that major release runs on a 2-month build cycle. So on full completion of rollout of Kix, DB2, and code within GitHub, we are looking to turn up the heat on the number of major releases and move from once a month to probably once a fortnight. And how do you manage the test data to populate the DB2 schema in each environment? Okay, so it's not cut from production anymore. One of the innovations developed by our quality engineering team, we call data as code. So data as code basically means that they have a set of APIs which will exercise the bank. So at the SIT level, you have got all the bank's applications all connected together. So data as a service, not data as code. Data as a service will simulate, for example, a new customer. So it's 100% manufactured. So you can go and say, I want a new customer with a current account, and I want to issue them with a debit card. And the data as a service will call the APIs on the customer database to create a new customer, call the APIs in the banking platform to create the current account, call the APIs in the card platform to create the card. The batch will run every day like production, and everything will happen, and you will be given a new customer who will have a new account, and they will have a card issued. Data as a service also has some enhancements on it, so you can age data as well. So if you wanted to age the customer by 10 years, the data as a service will go off and will know how to make the adjustments to the bank account and the customer record to age them by an appropriate amount of time. So we definitely avoid cutting data from production, GDPR and all that. There are still some circumstances where data is cut from production but then anonymized, but the applications are moving to 100% manufactured data. Certainly on my old team, which is the cards platform, it is 100% manufactured data now. Cool. Right.
Super.
Okay, no words now, Stuart. So let's crack on. So for delivery of code, so basically on the left-hand picture is the kind of logical view of things. So we've got a get flow branching strategy set up within a repo. The branches within the repo map to entry points within Endeavour. So in Endeavour, so the UNT and the DV and the dev layers are created dynamically. So everything that's in that bottom box is dynamically created. And so those are spun up and aligned to initiatives. So each of those UT and DV layers map to a ZDT. So a ZDT for a developer sandbox and another ZDT for functional test. It hangs together using webhooks. So webhooks are emitted by everything. So we capture webhooks from Endeavour. Those are translated through the Endeavour Git bridge into, again, web service calls that go into GitHub Enterprise. That's how code flows from Endeavour down to GitHub. And as the developers take action on GitHub, such as committing code, then webhooks fire, which are then picked up by the Git bridge, which then triggers source to be pulled from out of GitHub and returned through the bridge back up to Endeavour. Okay. Right, so demoing. This is where you have to bear with me for a second because I'll need to stop sharing and reshare again. So Stuart, if you can just confirm that we can hear Jules's dulcet tones. So the demos are narrated by a couple of colleagues. So Jules Stuhler from Triton, who works with the DevOps series at Lloyds, and Craig Coburn, who is a developer with the cards team.
Hey, Reg, we're still seeing the PowerPoint.
I'm just about to flip the switch. 1 second.
Brilliant. There he is, the original artist for all that fantastic artwork on the slides.
Okay, so in this demo, we're going to be talking about how to use GitHub Enterprise as a repository for the definitions for our Kix application objects. So things like transactions and programs and files and Eurimaps, and how we use IBM's Kix Explorer, which is a plugin for Eclipse, as a means of allowing people to easily view and edit those definitions. And then finally, how we will be able to go about and make changes to those definitions and have the automation deploy them to our back-end Kix systems. So we're going to start here on the left of the screen. This is a GitHub Enterprise repo that we have available here. And this is a repo which is dedicated for our use for this particular set of Kix definitions. We've got, as you can see, several subfolders inside our repo. We've got a config directory, which we store some configuration files that's used by the process. And then we've got these three main directories here. Each one of these corresponds to a Kix group for our application objects. And we hold all of the objects for that particular group inside the subfolder. So if I click on this test group, you can see we've got just a couple of objects in here at the moment. Prog1, which is a program, and TRN1, which is a transaction. And these are actually XML definitions which are produced by the Kix Explorer. So if I click on it, you can see we've got some fairly ugly, badly formatted XML inside here, but we can see that there are individual attributes here. So we've got the name and we've got the various attributes which are used for a KICS program that have been defined for this. And again, if I go back and look at the transaction, again, we've got some fairly ugly XML, but we've got all of the various attributes that you would expect to see for a KICS transaction. So that's how it looks from the GitHub Enterprise perspective. If I just switch over now to KICS Explorer, KICS Explorer setup here, and what we have here is a Git plugin integrated into our Eclipse, and this is essentially the same repo that we were just looking at, this KICS deploy no bundle. The same repo, we've got a local copy of that, and if we go down and take a look at the working tree, there's that config directory. Those are the three groups that we had, and we can see exactly the same objects inside there that we previously looked at. But of course, what the KICS Explorer gives us is the ability to look at those objects in a nice way. So here's the program that we could see earlier on, and those are all of the various things that we saw inside the XML. There's the transaction. Notice we've actually got an object here that represents the KICS group. This is actually, in KICS Explorer terms, it's a bundle. And we're kind of misappropriating a bit of the functionality inside the KICS Explorer here. This is intended to allow you to define a KICS bundle, and for that bundle to be defined as a bundle to KICS. We're not using it that way. We're basically using a bundle inside KICS Explorer here as a convenient mechanism to be able to collect together all of the various resources necessary. They are deployed in the back end as individual objects, not as a bundle. So apologies for any confusion that might cause. You can see inside this bundle definition, we've got a couple of existing objects that are there. And as part of this, we're actually going to go away and create a new couple of objects inside this test group bundle. So if I say new, and I'm going to say a new transaction definition, so we'll get prompted for the name of the transaction. We're going to call that GSE1, and we'll give it a description here, GSE demo. We've got this open editor checkbox ticked here, so that when I do actually provide a program name for this, which we're going to call GSEPG1A, then I can click finish, and it will drop us into a edit session here to allow us to go away and change any of the values to allowable values. So I can go through here and change any values here to any of the allowable values. So that's the advantage of having a nice front end like the KICS Explorer here. It's guiding us through what the allowable values are for these various objects. So we can get that set up the way we want. We'll leave the rest of them to default. I can go back here now and create a new program definition to match the program that we just talked about. So that's GSE EG1A. Again, I'll give it a comment, GSE demo. And again, we're dropped into an edit session here, and we can go away and set these up with whatever attributes that we want to go use to get set up. So having created these things, I will now just save those definitions. So we've saved those definitions into our local repo, and you can see here inside this Git staging tab, we now have 3 unstaged changes. We've got the 2 new files that we created, GSE1, which is the transaction, and GSEPG1A, which is the program. And we've got an XML file which represents the bundle definition that's been changed. So before I actually deploy these, I'm just going to switch over to a mainframe session here, and we can see what these things look like on the mainframe. So you can see the naming standard here. We've got a high-level qualifier. This hash base indicates that these are the base definitions. They haven't been tailored for any specific backend Kix environment. So we do have the ability to do things like parameter substitution to substitute in specific values for specific environments. Then we use the Kix group name, which is also the bundle name. So that's test group in our case. And you can see here we've got the two existing objects that we looked at earlier on. And if I just browse them, you can see we've got a slightly more nicely formatted version of the same objects that we looked at inside GitHub Enterprise earlier on. So what we're going to do now, switching back here to Kix Explorer, I'm actually going to stage the changes for the files that we've just changed, and I'm going to provide a commit message. And in the same way as we do with the DB2 automation, this commit message actually is our change ID. We're actually going to tag this with a unique change ID, which we will use when we come to actually deploy this set of changes later on. So I'm going to call this C211028. I'm going to say commit and push, and our Eclipse Git plugin is now going to commit those changes with the message that we just provided and push that to our backend GitHub repository. So that now, if I can just pull up the right browser window here. So this is basically a Git repo, which is the target for our particular set of changes. So we have a trigger in place that will allow us to actually go away and kick off a build. We can see here there's a build that's just currently in progress. It's just been kicked off as a result of that GitHub trigger invoking our Jenkins build. And if we look at the output for this, we can see the 4 programs inside our bundles. So there's the existing TRN1 and prog1, but we've got our new program and our new transaction that have been included in this. So this little step is just doing some formatting of the XML files to get that pretty XML format we see on the mainframe. And what we're doing now is going away and invoking an urban code process to physically go away and deploy those data sets to the mainframe. So this is being deployed against an environment called D1plex. That's our real development mainframe environment, this one here. So if I just go to history inside here, we should see an application process that is still running or has run against D1plex. Here we go. This is the copy process. So if I go away and take a look to see what this is actually doing, you can see we've got 2 major steps in here. The first one is running some static analysis against the XML that we've just created. So we're using a product called SonarCube, which is a static analysis tool. That's running some basic checks against Sonar to allow us to essentially conduct a QA review, a quality review against the XML. If we saw any bad code smells, if we had any rules being broken as a result of that check, this step would fail and the files wouldn't be copied up to the mainframe. But as you can see, we successfully passed that quality check. So we go on to running the process actually on the mainframe platform itself to basically go away, take those XML files and copy them through to our mainframe datasets. So you can see here we've got our new transaction GSE1 that's been copied up and our new program GSE PG1A. So if I now switch back to our mainframe session and I just do a refresh here, we can see we've got those 2 new data sets now that we've just created. Not many attributes here because we didn't specify many attributes when we actually created them. We just left most of these to default. But you can see that we've got our basic set of XML definitions for those 2 new objects. Notice now we've also got a manifest data set as well that contains within it a definition of the 2 new objects that we just created, and that will be used to drive the scope of the deployment. So when we actually deploy in a moment, we're going to be specifying our change ID, and that will drive the scope of what we're going to do. So that's all we need to do in terms of the deploying the actual change. I've shown you the process for here for deploying to D1plex. We could just as easily go away and in fact we do inside this same process. We deploy to D1plex, but we also deploy to a a ZDT environment as well. So you can actually see, if I just step back here, that same process kicked off against a virtual mainframe environment, a ZDT. Because they run much more slowly, that process is still actually running. In real life, we'd actually go away and deploy to multiple backend environments, maybe to our test and our production LPARs as well, so that we've just got that version of the XML, the basic objects, deployed to all of our environments. Okay, so having done that, the next step then would be to actually deploy these new objects to a given KICS environment. So we go back to our environment section here, and we're actually going to deploy to D1plex. To do that, I'm going to request a UCD process over here in UCD. I'm going to say which process I want to run, and we want the KICS automation to go away and deploy our KICS objects. So that's the process we're going to ask UCD to run. We're now going to be prompted for some runtime properties, the most important of which is our change number. So this is the number that we provided in the original KICS, in the initial Git deploy, when we actually provided a commit message for our GitHub in change in our KICS Explorer. So we're going to provide that same one, C211028. We've got some options here as to whether we want to delete objects in the CSD before defining them, and how long we wait for in between each install command when we get to install these objects in the KICS environment at the end, and whether to continue if the process encounters a problem at any stage. We also get the ability here to be able to provide a specific KICS region to deploy to. I'm going to leave that blank, and by leaving it blank, I'm going to ask the process to go away and do a lookup to some metadata to decide which of the KICS backend regions to go away and deploy to, based upon the group and the objects we're actually deploying. So we've got some metadata which we maintain behind the scenes that will allow that to go happen. So we just click on next now, and we're going to click on submit deployment. So we're now going to go away and deploy those new objects against our backend KICS system. So you can see we've got a few steps here that we go through. The first major step it's going to do is to take those XML definitions, so the XML definitions that we were viewing here, and it's going to tailor them for our environment. So remember, I said earlier on that we basically hold these as base definitions, and we would want to go away and tailor those for the specific target environment that we're doing to make any parameter substitutions that we may have. We didn't include any parameters in our base XML definition, so essentially that's just going to be copying to some environment specific data sets. The next step we're going to go through is basically to check for changes to any sensitive attributes. So this will take a look at the definitions, take a look at what they look like currently inside our target CSD, and if any attributes marked as sensitive have changed, we're going to flag that in the email that we send through to the KICS sysprogs to get them to take a closer look. We don't expect that to come up with anything in this particular situation because these are net new environments. We're then going to send an information email to contain some useful information for this deployment. And you can see here we're currently pausing, waiting for a response. So this is where the KICS sysprogs will get a couple of emails waiting for them to approve this before the deployment can actually go ahead. So if I switch over now to my automated email system, you can see we've got a couple of emails that have just come in, 1425. We've got a default email from Urban Code, which basically just says that we're at a manual stage waiting for input. But the more useful email is the customized one, which the process produces, which actually tells us what that change number is. It tells us the target environment, the region that we're actually going to be heading in, who requested the deployment, so that's the deployment requester, and we've got 3 data sets here which are attached. The first one is the generated set of KICS definitions. So these are the KICS define commands to define the new objects that we've just created to the CSD for the environment that we're actually talking about. And because we had yes ticked on that deployment option, it's also generated some delete commands here Those obviously aren't necessary because these are new objects, but we've created them nonetheless. Here's the output of our compare process, where it's actually going to flag any changed sensitive and non-sensitive parameters. Because it's realized that these are all net new objects that we've created, there's nothing that's been flagged in terms of anything being sensitive. And then finally, we've got a couple of commands which are going to be issued after we've done the CSD update to go away and install these new objects in our target KICS region, this CTLBD TRA environment here. So we're using CDA install to go away and do the install and activate these new object definitions. So that the KICS prog gets all of this nicely packaged up in an email. Once he or she takes a look at that and they're happy with what it is that they've actually been presented with, then all they need to do within Urban Code is respond, say approve. They can, of course, use the reject option if they wish. They can put a comment in here if they wish that's going to get stored in the audit trail with Urban Code. And as soon as we say submit, we're going to go into the actual deployment part of the process. This first section here, we're going to be physically deploying those objects. So we're going to be running those define commands inside the CSD to go away and define those new program and transaction definitions. So that's all worked fine. We're then going to run the install commands. So this is going to physically install the new object inside our target KICS environment. So again, we saw those two install commands, and we can see those commands being executed here inside the KICS region. Those were both successful. And finally, we've got a step at the end here to go away and tidy up some temporary data sets. So that's it. That's those new transaction and new programs successfully deployed to KICS, are ready to be used by our users. That's the end of the demo. Okay, so welcome to this short demo where we're going to show how we can use GitHub Enterprise as an SCM to store our primary version of DDL and automatically replicate that DDL through to multiple backend platforms whenever a change is made. So here is our organization in GitHub Enterprise. We've got a repo set up here specifically for DB2 DDL. And you can see we've got a couple of major areas in here. We have got a database subdirectory with a whole bunch of DDL for individual table spaces. So you can see we've got the database definition itself here, and then we've got a number of individual table space definitions in here, and as well as the table space definitions, we've also got table definitions, view index definitions, all of the dependent objects for that particular table space. In addition to our database object in here, and we could of course have multiple of those, we've just got one in this demo. We've also got a config file in here, which basically shows the process which Urban Code environments we're going to actually use to go away and run the copies in, and what high-level qualifiers we're going to use for each of those. So in this particular case, we're going to be deploying to an Urban Code environment called D1plex and an Urban Code environment called ZDT APPDV 70941. Rolls off the tongue nicely. And over on the right here, you can see we've got our Urban Code deploy web interface. And for the particular application we're deploying to, you can see we've got a whole bunch of backend environments here, one of which is the ZDT environment. That's a virtual mainframe environment that we'll be using. And then another is this D1plex, which is a second environment we're using. So that's pretty much what it looks like from the GitHub Enterprise perspective. If I just switch over to a mainframe session now, we can see that the high-level qualifier that we're actually deploying to, if we go and look on the D1plex, we can see that through previous implementations, we've actually got the DDL for all of the various objects that we were looking at earlier on. If I just pick one of those at random and show you what's in there. So this is the actual DDL that we could see earlier on. And we've also got these things called manifest files, which basically are used by the deployment process to actually show which objects, database name, table space name, are actually inside the scope of any individual change. And our process will be generating a new manifest file as well as generating a new version of the table space that we're actually going to be using. That's this 58p table space here. And if we look here, we can see there's a couple of members in here already. One will be from the initial upload. The other will be from that change that we've just looked at, D210015. We would expect to see at the end of this a new member inside there being generated by our process. So let's switch over now back to Visual Studio Code. Of course, you can use any Git-aware editor for this, but we do have Visual Studio Code on here. We have the DB2 developer extension installed as well, which gives us some nice syntax highlighting as well for DDL files. So we've already got a local repo of that GitHub repo for the DDL. We've got that pointed and set up nicely here. So if I just open the file that we want to edit, which is 58, that's the one that we looked at, and I find the create table because it's actually quite a lot of create table space DDL. Here we have our create table for the table that we actually want to create a new column for. So what we're going to do at this point inside the DDL, we're going to create a new column, which is going to be called card PRD type. And that is going to be a chart 20. And you can see that the highlighting that actually comes up as a result of the DB2 developer extension that we've got here, and some nice little additional text. So that's it. That's all we're going to do inside here. We're just going to add a new column to this table, a nice simple change. If I just go away and do a save on that, then we have saved the new version of that in our local repo. We can see here that our little source control extension here is actually showing that we've got an unstaged file here. So I can go away and stage that change inside my repo, and I can then go away and commit that change. We have the opportunity to provide a commit message, and this is what we use actually for our change ID. So if I put in a change ID of D211027, that's today's date. Of course, it can be any convention that the particular application team want to use. So we've now committed that single change, and you can see the Git messages coming at the bottom here. I'm now going to sync that change. As soon as I sync that change, what will happen is that the webhook that we've actually got defined on that repo will fire a Jenkins build, and the Jenkins build will then kick off, find the changed files, and pass them to Urban Code ready to go and deploy to our target environments. So I'm going to go away and press on that sync changes, and we'll see those changes being synced up to the main up to the to Git. Go back over here now and take a look at my Jenkins. So this is the Jenkins build, which acts as a target for that particular environment. We can see we've got a build just kicked off in process here. So if we just take a look at the console output for that, amongst the many things that are going on here, you can see that we've actually got a copy process that's going on for the particular database and table space that was just updated. And we can see we've got a couple of different UCD application processes, one going to D1plex using the high-level qualifier that we just talked about, and another one here going to the ZDT environment going to the other high-level qualifier. So if I go back to Urban Code now and look at the history, what we should see is those two processes running, once against D1plex, once against that ZDT environment. I can go and look at these individual requests. The ZDT one will take a few minutes to run because ZDTs aren't that quick when it comes to running Java workloads, and that can be quite Java specific. But if I go back and take a look now at the history for the D1plex, which is a real mainframe at the back end, you can see that's already finished. Just expand that out. We can see it goes through various stages here in terms of copying files around and executing those copies. But if we look at the output file here, we can see that we actually end up copying a couple of files. One is our manifest file, which actually shows the scope of this change, just a single table space in this regard. And we can see the actual DDL file that's actually been generated as well. So finally, if I go over here and just refresh my mainframe session, we can see we've got our manifest file now. That's the change ID that I entered as the commit message. And we can see that we've got a manifest file that contains the database and table space that have been changed. And if I actually go to that table space, which is this one here, you can see we've got a new member in here, again, tagged with the change ID. And if I just find our table command, we can go back and take a look, and hopefully we'll see our CRD PRD type was the name of the column, and there's that char 20 that we actually added in there in order to instigate the change. So as a result of a single commit inside the GitHub Enterprise, we kicked off a process automatically that's deployed that change to potentially all of our environments. In this particular example, just as ZDT and a real mainframe, which we call D1plex. And that's the end of the demo.
How long is this one going to take? Because we are now at time. It's all very interesting, so I'm happy for you to run over.
The target is a ZDT dev test box linked to develop branch in GitHub, which has been mapped to a dynamically created entry stage in Endeavour. The ZDT has had the new DB2 column and kicks transaction added as we saw in the previous demo. Craig Coburn will now make a code change in Git to utilize them. So here's the before shot to prove that column's missing from our result.
So now what I'm going to do is flip into my IDE and make the code changes. So I've already got the production code checked out to our develop branch within Git. So within the IDE, I can go down the branch to the actual COBOL component I'm going to change, open up the COBOL component, and now I'll make the changes. Okay, now the changes have been made. What I need to do then is push this back to Git. So now I'll just commit to develop and push it back. Okay, and now that we've pushed the changes to GitHub, we are now in a position where we can deploy the updates to our ZDT dynamic environment. So what I need to do is jump into Jenkins and run one of our pipelines. So this pipeline will take the code from our physical mainframe and copy it across to our development environment. So there's a few steps in this. It basically pulls the DB2 components, KICS components from Endeavour load libraries and DBRM libs. It then copies it to a Nexus repository. And once it's on Nexus, we can then move across to our ZDT environment and start deploying there. Okay, so now what it does, the first thing it does is stop the KICS environment on ZDT. That's to allow us to update the underlying load libraries, which can't be updated while KICS is up. Now we're deploying the code to the ZDT environment from Nexus. The code's now deployed, so we're starting KICS back up again. Once KICS is back up, the last step we do is DB2 bind for the components that we've just deployed. DB2 bind is just running at the moment. Okay, that's everything complete. So the amended code should now be deployed to our ZDT dynamic environment, and everything's refreshed in KICS. So if I flip into Postman again and do the same request to the same API, hopefully we should see the new element returned. There we go. The card product type has now been added to this API and deployed to our development environment, ready for some further tests.
Stuart, I should be back now. Apologies for overrunning.
No problem. Definitely worth seeing. A couple of questions then, Reg. Would you see the need for data as code, whereby static data, e.g. interest rate changes, business rules, and some others are migrated along with code and database changes?
Potentially. It's certainly things we've explored in the past. It's more to do with trying to pin down effectively metadata for the organization. And that is something that there is a team ongoing looking at that. But yeah, I think data as code will be the next step.
Okay, and any thoughts on how you link your pipelines into change management platforms, ServiceNow, etc.? Do you find managers have less fear, push back on changes when using an automated pipeline versus manual approaches?
Absolutely. It's basically, it has to be automated. You're frowned upon for manual deployments. We use ServiceNow. The slight bit of smoke and mirrors at the moment is that of the code KICS and DB2 components, the code component is integrated to ServiceNow. So a change can't proceed if the change record is not in the correct state. And a future enhancement to the KICS and the DB2 pipelines is to do that integration with ServiceNow for those independently of code. So basically ServiceNow, again, is API enabled, and you can query the state of a change record, which is why we capture the change record. So if anybody caught the difference in syntax, Jules was putting in a date into the change record field where Craig actually entered CCID equals. So that would be in this case it was a dummy record, but would be the real task number in ServiceNow. for a real change.
Beautiful. Okay, right. This has been fantastic, Reg. 4BC is the session for feedback. I did post it into the chat at the very top. If people want to give Reg great marks for the GSE Speaker of the Event Award. So thank you very much, and have a good afternoon, evening for everyone. Thanks, Reg. Appreciate it.
Cheers, Stuart. Bye now.
Cheers. Bye-bye.
Bye, guys.